Hello. In this video I want to look at just a couple of loose ends when working with Boolean values and Boolean methods. And I think these are some more subtle sort of issues, but we're going to need to understand them eventually. The first is, I wrote this method that's supposed to determine if both left and right sides of the robot are dark. And it says, if the left is dark, and I've already written this method in a previous lesson, if the left is dark, then if the right is dark, return true. And if that's not the case, return false. And at first, this might sound like reasonable code, but when I hit compile, I get this error message, which I'm going to start seeing. And it says, missing return statement. And it lights up this closing brace here. Why does Java feel there's a missing return statement? So I could stamp my foot and get angry and say, what do you mean? I'm not missing any return statements. I have 2 return statements. Are you blind? But here's what Java really means when it says missing return statement. In fact, let's write this down on our board since it's going to be relatively important. Missing return statement really means there is some pathway through my method, and this is a method that returns a value. There's some pathway through my method that does not reach a return. And we can see that here. So let's see. If the left is dark and the right is dark, I return true. If the left is not dark, I always return false. But what's the scenario where I don't reach any return? If the left is dark and the right is not, I don't hit this return. I don't enter the else, and I get to the closing brace without reaching a return statement. So that's what Java is saying when it says missing return statement. And I don't know, maybe I meant to do this. Maybe I meant to say else return false up here. Or maybe let's compile and prove that that fixes the error. Yep. Or maybe I meant to say, you know what? I like it the way it was, but I'm going to get rid of this else. Now it says, if the left is dark, if the right is dark, return true, and then no matter what, it's going to false through to this return at the end and return false. So that's also good, and that also does the same thing. Let's take a look a little bit more. We could also observe that if the left is dark, really I'm testing that the left and the right is dark. In fact, I'm even using the word both, which is a key that I might want to have used an and. So maybe I like this version better. Compile and prove that it at least compiles. And potentially, maybe I say, ooh, look, when this entire expression is true, I return true. When the entire expression is false, I return false. Maybe I could have simply said, return that the left is dark and the right is dark. And that should also work fine. Okay, so that's exploring missing return statements, an error you will probably see multiple times as you start working with Java, probably multiple times even after you're done, after you feel like an expert, which, trust me, you'll feel like an expert one day. Let's see. The next thing we want to do, oh, I know what we want to do. Okay, I'm going to write a really stupid method. In fact, this method I'm going to write is so stupid that I'm going to call it stupid. There we go. Don't try this at home. This method is really stupid. And it's going to return a Boolean, and what it's going to do is it's going to make the current cell dark, then it's going to make the current cell dark, and then it's going to return true. Okay, so I'm going to hit compile on that, and it compiles fine. And this may be bothering you, one, because this method has a side effect and returns a value, and I told you we wouldn't be doing that, and we won't. So I'm just really messing with us here. But also, let's see, if I load my robot world, let's use this one again. If I run make dark twice in a row, what's guaranteed to happen? I'm guaranteed to crash, because either the first dark crashes because the cell was already dark, or the second dark is guaranteed to crash because I know the cell is already dark by now. So this program will always crash. It will never return true. What happens if I remove the true, by the way? What if I just say make dark twice and hit compile? I get, ta-da, missing return statement. So Java doesn't realize this program is always going to crash, and so the compiler is forcing me to have a return statement even though I know it will never be reached. Okay, again, I said this method is stupid, hence the name. so I'm not going to get too hung up on why on earth would you write that method, Dave. I'm writing it for fun because, I don't know, I'm feeling stupid. So what I want to do now, let's load my world again. I want to see some weird things, weird results of playing with stupid. So what if we say, let's just play around with Boolean expressions. So what if we say, and that method is in my swap file. I'll prove that to you again. Here we go, swap file, because that was the problem I was solving most recently. Swap dot stupid. What should it do? Well, it should make the cell dark, try to make it dark again, and crash, right? No true, no false. It just crashes. What if we say stupid and front is clear? What will that do? So you may be thinking, well, the front is clear, so that's true. Let's see what stupid does. But stupid crashes. What if we say stupid or front is clear? Well, the front is clear, and or means at least one of these things is true, so shouldn't that be true? Nope, because ands and ors are evaluated from left to right in Java. So first, Java evaluated the stupid expression, which crashed, and so Java never had a chance to evaluate front is clear. Alright, so far no big surprises. Let's try something fancier. Suppose we say front is clear and stupid. What should that do? Well, that'll crash, right? Because the front is clear and only returns true when both are true, so it's going to test stupid, stupid crashes. Let's try front is clear or stupid. Any predictions? True. The program doesn't crash. Why doesn't it crash? Because of something called, in fact, let's write this down on my board. It's a word I will probably mention periodically. Short circuit Boolean. Short circuit Boolean means Java says, is the front clear? Let's say, yes, the front is clear. And because or means at least one of these conditions is true, and or is evaluated from left to right, Java realizes, hey, front is clear. That's true. I don't care what swap stupid does, because I already know the answer is true, and we get back true. Which is kind of funny, but it turns out extraordinarily useful. But when we get to more and more ambitious programs, we will count on this fact that Java will test the first condition first, and that if it's true, it will not evaluate the second expression of an or. So we like this. Or at least we find it interesting and tricky, and we worry it will be on a quiz someday. Let's see. Front is clear. Because it's true, we don't evaluate the second part. Is there a... In fact, let's put that on our blackboard, because that also seems important. So short circuit Boolean, let's scroll a little faster, means true, a true value, anything that evaluates to true, or anything will give us back, in fact, let's switch colors, will give us back true. True or anything is true. How about and? Is there some condition we can write that when we and, we'll always get the same thing, even if we and with something that crashes? And there is, because false and anything should be false, because and means both are true. So if the first expression is already false, it doesn't matter what the second expression is, the answer is going to be false. So Java won't even bother evaluating this second thing, even if it were to crash. So false and anything is false. Let's see if we can set that up in our program here, or in our interaction pane, or whatever it's called. False and anything. So let's see. What's something that's false? Well, robot, not robot front is clear is false, right? The front is clear, so not front is clear should be false. False and stupid, and according to me, that's going to be false, and it's not going to crash. And sure enough, it's false, and my program doesn't crash. So I think this idea of short-circuit Boolean is going to come up more and more as we write more and more ambitious programs. So just bear this in mind. I'll probably remind us many times as we reach programs that exploit this fact. And I think that pretty much rounds out just about everything we can throw at you regarding Booleans at this point in time. Stay tuned for the next video.